Tara Tom here. I'm so appreciative that you're with me today. We're going to talk about Amazon Redshift. I want to say two things about this product. Number one, massively parallel processing. That's one of the big concepts. And number two, columnar storage. And we're going to understand both of those right now. I want you to think about parallel processing. It's just like you go into the laundromat and it is empty and you can do all of your wash because you can do a bunch of the machines at one time, and then you can do all of your dry in an hour and a half. You see, that's how parallel processing works. Now, whenever you think about Amazon, they've got parallel processes. They're called slices. But don't think of these slices like you might think of the word slice. Think of it as its own PC. Take a look here. You can see that I have got 8 personal computers. But now they're all attached via a network. That's the way slices work because just like a PC, each slice has its own CPU, its own memory, its own disk, its own operating system. In a sense, it's a separate entity, but it's attached to a network and it's got a host always barking orders so that they can work in parallel. Now, let's talk about an Amazon Redshift system and how it works. When you create a table on Amazon Redshift, you will tell it the distribution key column, as you can see right here. Now, the minute you create that table, that goes to every one of those slices. If there are 1,000 slices on your Amazon Redshift system, then 1,000 copies of that table structure are out there because each one has the exact same tables. Then when you go load this data, it takes the distribution column or the distribution key and says, this is the order table. What is the distribution key column? They go, it is order number. They begin to do a math formula on each row's order number and say, order 1, 2, 3, you're going to PC4 or slice 4. The brilliance behind that is if you run a query and say, select everything from my order table where order number is equal to 1, 2, 3, the system does the math again and says, let me do the math on that. Order number 1, 2, 3, that is on slice 4. Only contact them. So a distribution key will lay the data out, and if you use that column in your where clause, they know exactly which slice to contact. Now, this is an important concept. I was confused when it came to Columnar. I just figured there were columns all over the place. Not the case. What they're going to do is whenever they lay out the rows, they're going to have the distribution key. Those rows will go to each different slice. So even though all the slices have the same tables, they'll all have different rows. But when they get those rows, they're going to split up each row into a columnar format. So if you've got a row that comes in from the order table that says order number, customer number, order date, order total, Amazon Redshift is going to make sure that a slice gets the entire row, but then it says, only the order number goes into this block of data. Only the customer number goes into this block, the order date into this block, and the order total into this. They've got to keep it perfectly synchronized in case they have to build that row again. So the very first entry in the order number block and the first entry in the customer number block and the first entry in the order date and the order total blocks will represent that row if they have to rebuild the entire row for the report. If someone says, select the average order total, they go, slices, just move your order total column blocks into memory. It's just a sliver. That's the brilliance behind Columnar. Where row-based is better is if someone says, Give me all columns on the report. Then it's just one big lift after another where the columnar has to say, okay, get everything organized and start lifting all these smaller blocks. So it's almost like a truck versus a series of motorcycles. If you've got to do heavy lifting, row-based is better. But when most queries are only asking for a couple columns in the select list, or they're doing any type of aggregation or calculation, columnar is real difficult to beat.